Now, I'm not normally a fan of taking shortcuts or cheating, but in this presentation, I'm going to tell you to do exactly that. So I want to find tricks for Pedi resuscitation that make it easier and more effective for us. All right, let's start with the initial premise, is that operating under stress affects you physically and psychologically. Your heart rate goes up, it deteriorates the ability for you to do fine motor skills and open vials, start IVs. Studies have shown that it impacts things like concentration, decision making, short-term memory. All these things are impacted as your stress levels go up. And there are very few things that are more stressful than a pediatric resuscitation. Lieutenant Grossman wrote a book called On Combat. If you haven't read it, I highly recommend it. It's a great book. He spends a lot of time talking about the human physiologic response to maximum stress situations. And obviously, getting shot at in combat would be a very prominent and significant stressful situation. But he has coined this term going from condition white, where you're relaxed, there's nothing going on, to yellow, red, gray, and then black. And once you get into condition black, your ability to perform really degrades very quickly. And so you want to avoid getting into that condition black. Now let's do a little bit of an experiment. Even though this is a recorded slideshow, I want you to answer questions aloud as we go through these next few things, because this will just demonstrate some of the psychology of using pathways in the brain. All right, so the first thing we're going to try is proof of mind reading. On the next slide, I'm going to show you several words, and I want you to put them in alphabetical order within 10 seconds. Okay, are you ready? Here we go. All right, 10 seconds are up. Now, I want you to think of a tool and a color. Put that picture in your mind. You can even say it out loud right now. How many of you picked a red hammer? All right, so in fact, about 80% of people will think of a red hammer. So why is that? Well, we're going to talk about it in just a minute. We're going to try something else. I'm going to show you another slide. I'm going to give you 10 seconds, and then I want you to recall how many different letters you see. Okay, are you ready? Here we go. All right, that was 10 seconds. All right, tell me right now, kind of write down, think about it, how many different letters can you remember seeing on the previous slide? If you're like most people, you'll be in the range of about 7 to 9. There's actually, I think, 13 different letters. But let me show you the exact same slide, just I've moved the spaces. All right, so I'm going to rearrange the spaces in this slide to this. Now, if I ask you how many letters, you'd be able to reproduce this very easily. All right, so why did you come up with a red hammer in 80% of the people? And why is it easier to remember this grouping of letters than the other grouping of letters? Well, your brain has shortcuts to help you process information. Like a lot of people have a generic tool, which is a hammer. So after having some cognitive task, like rearranging something in alphabetical order, your brain switches and uses shortcuts to say, all right, what's my most stereotypical tool? Hammer. What's my most stereotypical color? Red. Same thing with things like NASA, JFK, the IRS. You already have a framework in place to remember those, so it puts it into context very easily rather than having this other jumbled thing. So for doing an adult resuscitation, if an adult is cardiovascular collapse and you're going to give a dose of epinephrine, how much do you give? It's very easy. You give one of the vials. You give 1 milligram. How much of this 50% dextrose? Same thing. You just give the vial. If I ask you how much diazepam you need to give for a seizing adult, you could probably come up with that very quickly off the top of your head. A lot of you will say 5 milligrams or 10 milligrams IV. Um, and then if you've heard me lecture before, I typically have 2 doses for etominate and 2 doses for succinylcholine in adults, right? So if you're a small adult, you're going to get 20 of etominate and 100 of sucks, and if you're a big adult, you get 40 of etominate and 200 of sucks, right? I take my guesswork and thinking and calculation out because I know that those doses will do well enough for what I need to accomplish, and it eliminates one of the complicated tasks of doing math in your head in a crash situation. All right. So you know the adult doses of epinephrine and dextrose and things like that. Let's try this for pediatric patients. All right. So I'm going to give you 3 different peds patients. You're going to have to estimate the age, you're going to have to estimate the weight, and then you're going to have to give me the doses for epinephrine, dextrose, and diazepam. All right, you ready? First kid, what's the dose? What's the weight? How old is he? You know, if you've got a crash situation, you've got a code, you got to come up with quick. How about this one? Or this one? All right, so you're probably thinking in your mind, trying to come up with weights and estimates, and then doing multiplication to come up with a dose for these. My contention is that doing that under maximum stress situations is probably not ideal. I think we need to make shortcuts. I think we need to fake it till we make it, right? So what does that mean? Create generic weights, right? So if you get a kid that's really, tiny, really skinny or frail, or really obese, now this may break down and we have to use Brazlo tapes or other methods to help us, but we can use generic weights and make it easy for us. So if you have to estimate an age of one of these kids, come up with an age that fits one of these models. And we're going to talk about why this is important in just a second. All right. I want you to shout out the answer to these math problems as fast as you can. Ready? All right, that's pretty easy. How about this one? Perfect. Last one? All right, you probably got this. Didn't take you too long, but the other 2 were near automatic. This one causes you to pause, right? Because this breaks preset frameworks in your brain with multiplication of 5s and 10s, something that you could do very easily and quickly, to something that you now have to figure out and carry a number and put it all together. So here's a list of typical medications that we give in pediatric resuscitations, right? And here's the dose. And if you notice something interesting about the dosages, it's all multiplying by 1, or sort of moving a fraction, 0.1, 0.01, so you're moving a decimal point, or 10, which is easy, you just add a 0, or 2, all right, where you just double a number, 5, right, and everybody can work with 5s pretty well. So it's very interesting to know that the doses of medications are arranged in a way that it should make the math fairly easy to do. All right, and so this is from Dr. Antevi, who's created a system called the Hantevi system, and you can go to hantevi.com and see more about it. And he's got a service that you could pay for, and he'll come in and do training and create books for your system. And he's based this off of a study that was published that showed that this type of system works really well. It works as good, if not better, than some of the length-based systems. And these color codings match the Brazlo tape colors. But the way this works is you've got 1, 3, 5, 7, and 9-year-old kids, and the weights correspond to 10, 15, 20, 25, and 30 kilos. So if you use this model, then you can say, all right, a 1-year-old's 10 kilos, he's going to get 1 milligram of epi, he's going to get 20 mils of D25 and 0.4 mils of diazepam. And this makes the math and memorization a lot easier. And you can create basically cheat sheets that have this, type of thing color-coded. And there will be a link below in the description of this video that will take you to a link where I've created one for the College Station Fire Department that I work with. But this, takes the math out. So when you're in a situation that's like this, right? You don't want to be this guy. When you use something like the hand-heavy system, it gives you a quick framework that allows you to do simplified math, so you can be like this. All right, that's it for cheating and making shortcuts. I think knowing about human physiology and psychology and the way that our brains work, we need to take advantage of that and use things to improve our ability to function under maximum stress. Thanks for watching.